This is a tutorial on error handling in Python. Sometimes the Python program is going to encounter an error, and either Python can handle that error and report a problem, or else you can do that yourself. For example, here in this example down here at the bottom, you see a divide by 0, 5 divided by 0. And so we're going to put that into a try except block, and we'll try to do this. There will be an error. And so then we'll catch that error and then assign y equals infinity and then proceed with our program. If we didn't have that there, Python would report an error and stop the execution of the program. So sometimes we want to be able to handle that error differently and be able to continue on with the rest of our calculation. So this assignment here is going to cover a couple things: error handling, raising exceptions, and then some custom error messages. We're going to mostly use the try and except block, but there are other options as well that I'll share with you. If you'd like to follow along with this, just come to the course website and you can follow along with the IPython notebook that's available for download here, or you can just go to the CL6, the Colab 6. That's going to be our the assignment. Or if you come here to the GitHub page, then that will be all of the assignments here. This is going to be homework number 6. Okay, so I'm going to come back here, and there are either, a lot of times there are either syntax errors or runtime errors, where logical errors or other things in your program. Syntax errors are probably the most easy to fix because it'll catch that typically when the program tries to run. So let's fix some of these errors right here. If we run it, we can see that it says invalid syntax here, which is not really true. The syntax is fine there for importing NumPy, but the real problem was that I just forgot a parenthesis. So the main point about that is that just look above and below the line. Sometimes you're missing a parenthesis or something like that, and so you need to just check around that area for the error. Okay, so I'm going to go ahead and run this again, and it says that I have an invalid syntax, okay, which is this f of x, and so I'm going to fix that one now, but that was not actually my next error. Okay, I have another one here that says if x is equal to 2, it says invalid syntax. We need to compare those two, so I've got to do a double equal sign there. Let me run it again, and then we see that it did print out the 5, but now there was a runtime error here. It says module NumPy has no attribute 0. So it didn't even catch this error until I'd fixed some of these other ones. And then I'm going to change that to zeros. Okay, and that's going to create a NumPy array of 5 zeros. And then if I run this again, it's going to catch another error. Okay, so here it is, 3 plus 2, but we're trying to add together an integer and a string. So I want to make this I could convert this to an integer if I had that in variable form, okay, and or I could just get rid of these quote marks, and that would equal 5, and then I would return 5 squared from this function. Okay, so I fixed some of the errors right here. I'd encourage you to go through these again on your own and just look at the error messages and see if you can figure out where that error is. So this is an example of Python throwing the exception or the error, and then you can look at the error messages. Sometimes it's a little bit cryptic. Again, look around that. The error was actually up here to begin with, but it reported that the error was here just because I had missed a closing parenthesis. Okay, let's go on to problem 1b. Sometimes these runtime errors can only be found after the program begins, and so if I run this, I'll see that it reports a 0 division error. Okay, float division error. And what we want to do is we want to check the value of x. So I could do something like if x is equal to 0, then I could say we want to return np.inf infinity, and else we could return 5 divided by x. Okay, so we could do that just with an if statement, and then we would return infinity instead. Now if you wanted to, you could print a message here. Okay, divide by 0, for example. Okay, and that would just give you a warning. So this is one way to do it. We can also use something called a try except block to catch the errors. So for example, here in action 1C, we have this try except block where we try to run this line of code, and if not, then it will print out a warning message in the except area, and then we would set y equals to np.infinity. Okay, so we're going to change this function now. Right here, we'll change that function to use the try except block instead of the if statement. And so I'm just going to try to do y equals 5 divided by x, and then I'll say except. Okay, and here is I can just say that divide by 0. I could set y equals that, and then I could just return y. Okay, and that does the same thing as before with the if statements, but now it catches any error that might happen with that line, and then if it is unsuccessful at executing that line, then it executes these lines instead. Okay, so that's a very basic way of using the try except. But let's go on. These are all the different types of exceptions, and so we can, as we saw, there was a divide by 0 that we had before. Let me just print that out again. 5 divided by 0. We had this 0 division error. That was the name of the error. And then there was the description, division by 0, and it pointed out the correct line for us. But if we just look for this in the table, we'll see that that's one of the many standard errors that are reported by Python, or could be reported. This is going to be in the math exceptions. And it says it's raised when division or modulo by 0 takes place for all numeric types. Okay, so this is just one of them. There are others as well for input-output. There are some others as well. Okay, these are things that are going to potentially stop your program and report an error. And so there's things that we can catch explicitly. Okay, let's go on down to the next one. Okay, we're going to run through some of these tests with a try except block, but in addition to the except, we're going to put in the different types of errors that we might have, and then we can put as error in order to be able to print that error message or do further things with that error, the exception that Python caught. Okay, so we have 0 division error, and we also have a type error. Okay, let me go ahead and zoom back out here. Okay, I'm going to go ahead and run this cell, and it says we have this custom message. It went into this area and then printed the float division by 0. All right, and we can also have a finally in there, and that will be kind of like a cleanup step after it does the try or the except. Then it will do the finally, and so you can put some custom code there just to clean things up or do other things at the very end of this block. Okay, let's just change this from test 1 to test 2. Okay, we're going to try to add together a 5 plus a string, and then we're going to get a different type of error or exception. We're going to get a type error. Okay, instead of the zero division error, it's going to come into this area, and then it printed out this message. Okay, let's go on to the next one. Here's another one. This is going to be a different one where I'm going to try to open a file that doesn't exist. And then this is going to be caught by the general except, and then I'm going to raise a new exception here in this except block. And you can see it's the file not found error. Okay, and that was in the table here. Let's just see if we can find that. Here's the file not found error. Okay, let's go on to some additional ones. We can also use the raise. Instead of just raise there, we could raise an exception with a certain message there. So let's go ahead and just put that in here. Instead of just printing another error, we could instead print some custom message, okay, another error too, for example, and if we run that, then it just says exception, and then it puts our custom message there. So we raised our own exception, and we're able to print something that would be custom here, and it just says there's an exception that happened. Okay, and it did point out the correct line where that error occurred. Okay, let's go on to the next one. We'll modify the divide to print a warning message and return NP infinity when attempting to divide by 0. Okay, so let's just go ahead and do our try, and I'll just say y equals 1.0 divided by x, and then we'll do the except. Okay, now in this except, we're going to go ahead and catch the divide by 0. Okay, so this is going to be our 0 division error. Alright, and so we really only want to set this equal to infinity when there is a 0 division error, and else, except you could do something else, and then we'll return y. Okay, and then if we just do divide 0, okay, then we get infinity, and if I put 2 here, then I'm going to get 0.5. Okay, so this is just exercising some of those things that we've already done. Alright, now let's go ahead and just further include in this divide function, if we put in a string, then again, that's just going to be except, and then I could have type error, and I could say y equals 0 if that happens. Okay, or I could do something else that's custom. Okay, so that's just to help you practice these try, except, and identifying which error it is, and then doing something custom based on what that error could be. Okay, you can also do an assert statement. An assert statement checks for conditions and halts the program execution if the condition's false. So I've done this a few times. If you have a particular program that only works on one platform, for example, or you want to be able to check certain conditions so that your program is going to work, you can run the assert. Okay, so I'm going to run this. Okay, this code only runs on OS 2. So what I want to do is just first of all print what is my platform, and platform. Okay, so that says it's Win32. So Windows, any versions of Windows, including Windows 64, is still going to be Win32. And then I just printed this. So if this code runs on any other platform, it's going to assert and raise an exception and with this message right here. Okay, so I would just change this, for example, to something like Windows only. Alright, let's go on to the final problem here. This is more of a real problem where we're going to be checking the tank height, and this is we want to be able to calculate the volume of crude oil from a flow and time as input arguments. So we're going to create a function to do that, and then we want to create another function that's going to calculate the volume of the cylindrical tank from height and the radius of the tank. So let's say we had a tank. The volume of that tank is going to be pi r squared times the height of that tank, and this is going to be at a certain level, and then we're also going to have some flow coming into this tank, and that flow for a period of time we'll be able to calculate if the tank is going to overflow. So for the very first thing that we want to do, we're going to calculate the volume of crude from a flow and a time. So let's just say the volume 1 as a function of the flow and the time. Okay, and then we're going to return the flow times the time. And that's going to be our first volume. So let's say we just had volume 1 and there was a flow of 1.2 for a time of 5, and we're just going to print that answer. Okay, that's going to be 6. Alright, so let's do the next one, which is going to be calculate the volume from the height and the radius. Alright, here's our volume 2, and so we have the height and the radius, and then we'll just return np.pi times the radius squared times the height. Alright, let's do the same thing here. We'll just print this out, and then we'll do some of our try except blocks in checking the conditions of the tank. Okay, so let's say I had a height of 1 and a radius of 2. Alright, there's going to be my volume of my tank. So this one is not going to overflow because I have only 6 meters cubed of crude oil, and I have 12.6 for the volume of my tank. So we're going to use the two functions to compare the volume of the crude to the volume of the tank. Okay, this is a fairly simplistic problem, but it helps us practice some of the things that we just found in the prior sections. So if the volume of the crude is greater than the tank, raise an exception with the message tank overfilled with the volume that is spilled. Otherwise, print a message tank not overfilled with the remaining storage capacity. Alright, so let's go ahead and test these two. So I'm just going to do if the volume 2 okay is going to be okay, and then I'm just going to put in this same one that we just had here. Okay, this is going to be our okay, let's do volume 1. This is going to be our tank, the amount that is filled in our tank. So if this is going to be greater than, okay, and then I would put in 1.0 and 2, and this of course should not be overfilled. Okay, but we're going to print a message here with raise exception, and then we'll say that tank overfilled, and I'll do a formatted string here. I'll do an F here, and by, and then I could put in the difference between those two. So I could just copy this in, and I could put a minus sign there. Alright, so I've included that, the exception and else, and then we'll print out tank not overfilled, and then we'll run it. Okay, so tank is not overfilled, but let's go ahead and just increase the amount of flow that's going into that tank to 3. Okay, and then it's going to raise an exception, and it says tank overfilled by that amount. And it looks like I just got the overfilled amount, the negative of that. So let me just go ahead and, okay, so it's overfilled by this amount, and I better put the meters cubed and I could just format it a little bit more, nicely, so it gets rid of some of those decimal places and says how much it's overfilled by. Okay, so the program execution will stop because I raised an exception, and then I gave it a message that it should print, and it did that right here. Okay, so this would certainly get your attention if you're running this program. You know, overfilling a tank might be one of the reasons to stop the program and report an error. Okay, let's go ahead and test it with our functions and our program with these values. Okay, and then I'll just plug them in here. Let's go ahead and do it for the tank. And in this case, we had, okay, the flow and time, and then the height and the radius. So V1 is going to be the flow. Okay, so that's going to be F, and then this is going to be T, and then this is the height and the radius. Okay, and then let me go ahead and just replace these other ones here as well. Okay, with V2, I just need to replace this one, and then also replace V1 as well with the symbols instead of the values there. Okay, I'll go ahead and run it. Okay, so it looks like that one is overfilled, and let's see. It looks like V1, let's see, V2, I think I got that wrong again. Okay, so V1 is greater than V2, and it's going to raise this exception. Oh yes, okay, so I guess I did get that wrong from before. Okay, V1 is going to be greater than V2, so let me put it in like this, and then there's the amount that it overfilled by. Alright, so we have this one where it's overfilled due to the flow, and then there's the volume of the tank, and so we just printed out the difference between those two. And I guess this one, I made a mistake up here. This one should have been V1 divided by minus V2 if that was greater than. So let me just fix that one. Okay, and it looks like I've got something here. It says it's overfilled by negative, but V1 should have been greater. Oh, that's what it was. I forgot to put a 3 here. Okay, so there's the correct syntax. Okay, so I shouldn't have switched those after all. All right, let's go down here. Okay, tank not overfilled. Let's go and test it with our next set of conditions now. I could create a function for this, so I don't have to keep copying this down, but just for the sake of this exercise, I'll just go and copy these values in above, and then let's just test it. It says the tank not overfilled, and if you want to put the additional capacity in there, you could just do a print statement that would show the additional capacity that's left with let me go ahead and put that in there and make that a formatted string. And so in this case, V2 is going to be greater than V1, and okay, and this would be the spare capacity. Alright, so I've put just these, tested it on with these values, and then we used an if statement with a raise exception just to get our custom messages printed if they're going to overfill or not overfill. Alright, that concludes this tutorial. Again, if you'd like to get this list of exceptions, you can just get this. And these are also found online as well. But this is a fairly comprehensive list of some of the most common exceptions. Now, every package might have their own set of custom exceptions, and you can even create your own if you create your own class or your own module that you're going to use in Python. we'll cover some of that later when we cover classes in this course.